All right, so now let's talk about how we find a p-value when working with a significance test of a population mean. So they kind of get into this description of the t distribution. So if you remember, we talked about it in chapter 7 that we need this t to kind of give our interval, uh, the much expansion that it needs to create an interval that would capture the value. So when you look at these t distributions, they are symmetric, they are single peak, they're bell shaped. They have this degrees of freedom involved in it. And if you look here at the picture, the standard normal is this purple. Notice that what happens as your degrees of freedom increase, I'm sorry, as they decrease. So 9 degrees of freedom looks similar to the purple. But notice what happens when you go to 2 degrees of freedom. When your sample size is small, notice that your your uh your hump, your whatever, your peak goes kind of down right around your mean, and your tails get rather taller. So as your degrees of freedom decrease, you are allowing a lot more probability to happen on the outsides and less probability in the insides. So keep that in mind, right? So again, it talks about it's similar to the standard normal. It has more variability. Again, that's what I'm saying. As your t value, I'm sorry, as your degrees of freedom become less, notice that your tails get bigger, more probability in the outside. Okay, so t value can be larger because t distributions have more area in the tails. And as your degrees of freedom increases, your t distribution approaches. Sorry, this should say approaches your standard normal distribution. That's this, there should be an arrow there. Let me do that now. Okay, and there we go. All right, so cool. So a little background information about t distributions, but again, just know that you have to use a t distribution for uh, your means, right? So again, here's our example. So let's find the probability when t is less than or equal to negative 2.59 with degrees of freedom of 12 minus 1 equals 11. So you have to understand that in table B, it only shows positive t values and right tails. So if you look at the top of table B, right here, notice right there, see, that's a right tail area. And notice all of your values in your table are positive. Well, it's not a huge deal, right? If your t value is negative, you just simply use the positive one and pretend you're working with the right side when you're actually working the left side. So no big deal. So again, because this is negative 2.59, just think positive 2.59. And you're not going to necessarily find that in the table, but you're going to find two values that it's between. So you find your degrees of freedom row. So we find the 11 row, and we find the two values that 2.59 falls in between, and it's these two values, right? So 2.59 is right smack dab. So then you go up to the top, and you're going to find your p value interval. Now understand that they're not in numerical order, they're backwards. So make sure you flip them around. So for this, the p-value would be in between 0.01 to 0.02. So you're going to get an interval. You're not going to get an exact value. That's okay. It's okay. I don't care. You're going to get an interval. All right. So be aware of that. All right. And again, if the correct degrees of freedom isn't listed, always use the next degrees of freedom less than. Cool. Awesome. All right. So let's take a look at our last problem here. All right, so this kind of branches off of example 2. So again, suppose you want to perform this test that the alpha equals 0.10 significance level of null hypothesis mu equals 7. Alternative hypothesis mu does not equal 7. A random sample of size n equals 25 from the population of interest yields sample mean, sample standard deviation. We calculated the test statistic to be 1.125. Find the p value using table B. Assume the conditions were met. Now notice here that this alternative is two-sided. In the example I just did, it was one-sided. I think it was less than. So think about that as we go through this problem. All right, so my t is 1.125. My degrees of freedom will be n minus 1, 25 minus 1, which is 24. So on the table B, I'm going to find this 24 row, and I'm going to find the two values that surround 1.125. Okay, so let's go do that together. So if I zoom in here, I'm going to find the 24 row. So here is the 24 row right there. Find where 1.125 is. It's right around there. So I'm going to take a picture of that so I can write them down accurately. Okay. All right. So if you look at 24, 1.125 is in between 1.059 and 1.318, which represents p-values of 0.15 and 0.10. So in my notes, what I'm going to do is write this for this problem. So again, we had our degrees of freedom was 24. I'll write that down again. So from your table B, there were these two values. And again, let me go find them. Yes, it was 1.059 and 1.318. Those are the two values that 1.125 fell in between, again, in the table. So then your p value is going to be, and now, because of this two-sided, it's going to be twice or two times the um, values of 0.10 to 0.15, which means that your p-value is going to be between 0.20 and 0.30. This is your estimation for the interval of your p-value. Okay, so again, if it was a greater than or a less than symbol, I would have put 0.10 to 0.15. But because it's a not equal to, I have to double that because I have to include the right and left tail. And again, remember, where did I get the 0.10 and 0.15? I got them from on the table, finding my two values, which are right here, 1.059, 1.318, and going up to 0.15 and 0.10. And then again, I doubled them because of the two-sided test. All right, so again, try your best at this section. If you have any questions, let me know. I'm here to help.